Morning, everyone. Thank you for attending this celebration and knowledge sharing session with a few of our global experts. We really value your time. Thanks for being here. It's a real pleasure to welcome you. It's not just a workshop; it's a celebration. It's a milestone for us, and a chance to reflect over the last 20 years of doing things the hard way, the right way, and sometimes the South African way. Let me take you back. 20 years ago, our founder left a stable corporate job with a large chemical company. And like any good South African entrepreneur, he thought, how hard can this be? It turned out it was actually quite difficult. We started with global suppliers of pumps and chemicals, a bakkie and a dream. Well, not really the bakkie, but it adds some ambiance to the story. So anyway, I digress. The early days weren't easy. Business came slowly, clients were cautious, and it turns out water treatment wasn't as glamorous as it looks on paper. But those early tough years built a business that was strong and could survive in the real world, and more importantly, in Africa. From that very start, one thing was clear. This wasn't just about selling products, it was about showing up, understanding the problem, and fixing it, even if it meant camping next to a plant, with nothing but instant coffee, cable ties, and a few good guesses. True story. Pierre and Marius spent a few days outside the plant trying to sort out an issue with particulates, and that's how they built a reputation. One small, stubborn water problem at a time. We also started building long-term relationships, the kind that last not just through market cycles, but through load shedding, port delays, and late night calls from clients saying, the plant's doing that thing again. Our first long-term partner was Vista Technologies, which have since changed, been bought out by Kurita. For more than 15 years, they've stood by us, provided chemicals to us, for the desalination industry in South Africa, and working with us to make membrane systems cleaner, safer, and more sustainable. Then came Danfoss with an offering that let us combine high-pressure pump with energy recovery in one sleek solution. Finally, a way to get real performance without needing a mechanical engineering degree and a spare box of bolts. We've seen some wild things on this journey. From celebratory gunfire in Iraq after they've won a football game, and this was also not covered in our risk assessment, to flying into tiny African airstrips with nothing but a pump part, a passport, and a prayer. Over time, we expanded from South Africa to Mauritius, Seychelles, Mozambique, Namibia, Angola, Zimbabwe, Kenya, Ghana, Tanzania, Senegal, Cote d'Ivoire. Wherever our clients go, we go. We haven't been asked to supply into Antarctica yet, but we have a jacket just in case. More recently, we partnered with NX Filtration, a Dutch company with cutting-edge filtration, hollow fibre nanofiltration technology. It's high-tech stuff with one job: remove emerging contaminants simply and efficiently. And we love this technology because it fits the African brief perfectly. It's one step, low fuss, low energy. Now, let me just quickly pause to say the business has always been a family business, built on relationships, not just invoices. I'm actually the first non-family member to join the team, so yes, the pressure was real. They told me I was part of the family now, right after asking me if I knew how to reverse a trailer and how to fix a dosing pump with a teaspoon and some cable ties. Okay, but jokes aside, what's made us who we are is the willingness to stand by our clients through tenders, breakdowns, commission chaos, and those long Friday night calls that start with, "Are you busy?" And we also try to help, even if it's outside our scope or out of our comfort zone. The water treatment industry itself has evolved massively over the last 20 years. We've moved from basic dosing and softening to smart automation, energy recovery, AI, zero liquid discharge, and sustainable reuse. But what hasn't changed is the need for people who care, who know what they're doing, and is willing to pick up that phone call. That's what this workshop is about. Yes, we're here to share insights, new tech, and real project experience, but more than that, we're here to build something that has always driven this industry forward: trust, collaboration, and practical innovation. So thank you for being part of the celebration, and thank you sincerely for the relationships that we've built over the years and the moments that we've shared over these last 2 decades. So let's have a fantastic morning together. Welcome to the Marsi Water workshop. The agenda for this morning, we'll start with presentations from, firstly, Filtration, followed by Danfoss, and then followed by Kurita, where they will be sharing the technologies that they have in the market, how these technologies can be applied. Then we'll have a coffee break at 10:15, and then after the coffee break, we'll have some views on real-world insights, again from these 3 global experts. We are very privileged to have them here. None of them are from South Africa. They're supporting us from the various global offices, and we really thank them for their time and their effort to be here. So yes, without further ado, firstly we have Loreen Grobler from Filtration. She's the team lead sales engineering from the Enschede office in the Netherlands.
Thanks, Derek, for that introduction. Good morning, everyone. I would like to start just with an introduction of Filtration. We will go over to our application areas and then also our product portfolio. We'll touch on UF retrofits and reuse projects. So first of all, NX was originally started as a nanofiltration company in 2016, where our founder he produced membranes from the University of Twente, located in Enschede in the Netherlands. We are also based in the Netherlands in Hengelo. That's where we've got a factory. We say it's a world-class factory. We can produce up to 60,000 modules per year in this factory, with the possibility to scale up further to 120,000 modules. So that makes us the largest hollow fiber factory in the world. Our products is all hollow fiber membranes, so that ranges from nanofiltration to ultrafiltration and also microfiltration. We distribute our products through 5 regional sales offices globally, and since 2021 we've launched more than 400 projects. We are an ESG driven company, so we are fueled by innovation. And maybe just to mention, within our factory we treat the water that we use to manufacture our membranes with water from a nearby canal. This water is abstracted from the canal, directly treated by our nanofiltration membranes, followed by reverse osmosis, and then used to manufacture our membranes. So it's well known that water scarcity is not only in South Africa, but globally. And we see that climate change is actually, it's helping, well, not helping, but contributing to the groundwater sources being exhausted. So, taking that into account, about 60% of the world's population currently lives in water scarce areas, and that leaves 2 out of 7 people without access to clean drinking water. So, that being said, there is a need for alternative sources to be used instead of just groundwater. But these sources are usually polluted with micropollutants and medicinal waste. Just taking, for instance, the wastewater that we produce from normal domestic sewage, that is being treated conventionally, and that conventional treatment is not equipped to remove medicinal waste, for instance. And that effluent is just discharged into our rivers, where we then abstract water for drinking water, using again conventional systems which do not remove these micropollutants. So with that being said, there's a need for alternative technologies, new technologies. And with N-exfiltration's nanofiltration membranes, we can remove some of those micropollutants without the need for chemical use, so applying that water almost directly to the membranes. So going into application areas and the product portfolio. So as I've mentioned, we have nanofiltration, ultrafiltration, and microfiltration membranes. All of these membranes are hollow fiber. The nanofiltration range, we have two products, the DNF80 and the DNF40. And that is, the 40 is a 400 Dalton cutoff, while the 80 is a 800 Dalton cutoff. And these membranes were specifically manufactured or developed rather, to remove organics like your CODs and also micro from the water. Yeah, and this is basically without chemical dosing, so you don't need your coagulants and flocculants. So almost a one step. Our ultrafiltration range ranges between 10 and 150 kilodalton, and this is mostly for your, like for instance, RO pretreatment or wastewater treatments, and that is mostly for your virus and bacteria removal. Microfiltration is mostly used in the food and beverage industry, and our membranes are applied to clarify beer and wine. Okay, so first of all, I'll focus on the nanofiltration range, and we've seen in many cases that a traditional process, including coagulation, flocculation, your sand filtration, UF and RO, with usually a remineralization process afterwards, can be condensed into a simpler treatment step. Whoops, sorry, it's automated. So taking, for instance, a simple pretreatment like a strainer or in some cases a sand filter, and applying that filtrate to a hollow fiber nanofiltration system with a post-treatment can give you the same water quality or even better. So the nanofiltration technology is a patented technology. So in the first picture you see, it is a single fiber with the patented layer-by-layer technology. And this is a charge-based membrane. So the layers would be, the layer that is subject to the water quality would be negatively charged at pH of 7. So the second picture is what a module would look like from the top. So that's all of these fibers connected, installed in a module. And then the third picture is the vertical installation of a membrane system with the nanofiltration modules. Also, just to mention, our membranes, the membrane modules do have some drinking water certification. So NSF, QR, and ACS. And then, so if we would compare traditional nanofiltration to our hollow fiber nanofiltration membranes, what is the difference? So we claim that our membranes can basically take on more worse feed water quality. So that would be an increased turbidity, suspended solids, which we take around peaks of 300 ppm, and also CODs ranging from 100 to 1,000 ppm. Our membranes are chlorine resistant, so they can take chlorine up to 250 ppm hours at elevated pHs above 10. These membranes are also backwashable, so in many cases you would need quite extensive pretreatment with your spiral wound nanofiltration membranes, which is not necessarily necessary for the hollow fiber membranes. Two key applications for our nanofiltration membranes is surface water treatment and also wastewater reuse. So on the surface water treatment side, we do apply our membranes for drinking water. That would be, for instance, on a river to remove your organics, color from the water, and some micropollutants. And that water can then be used for drinking water. or also in industrial processes, dependent on the permit requirements. On the wastewater reuse side, we also we can do municipal wastewater. That's one of the sweet spots for our membranes. So after clarification, after the clarifiers, with a drum screen, and then followed by the nanofiltration membranes. The permeate then can be reused or even further treated for potable reuse. But I'll say more about that later after the tea break. On the industrial side, we've seen also, so for instance, pulp and paper, any wastewater that has been treated biologically can also be applied to the membranes relatively easy. So in both cases, the main parameters that would be removed is your organics, COD, BOD, color, and also some suspended solids, stability, and then your PFAS and micropollutants. So globally, we do have an installed base of nanofiltration membranes, mostly in the European region where we are based. But this slide is just to indicate to you that we do also have installations in other countries in the world, also in Asia, Indonesia, Australia, and also Northern America. Then just bringing up this slide again to highlight the ultrafiltration range. Like I've mentioned, smaller particles, 10 kilodalton to 150 kilodalton. The more tight membrane, the 10 kilodalton, is used mostly for silica removal, while the UF10 is the membrane that's usually used in for RO pretreatment, for instance. Our filtration principles also applies mostly for the nanofiltration. All our membranes are PES based. They are single bore and inside out. So that being said, with the PES membranes, should you use our membranes, you could be covered for future regulations where PFAS could become an issue. On the ultrafiltration side, main applications would be potable water, municipal wastewater reuse again, and reverse osmosis pretreatment. That's where we mostly apply our ultrafiltration membranes, and then also in industrial wastewater reuse. We've got a global base of ultrafiltration membranes, which might be something new to you because we are a nanofiltration company, right? So yeah, I will cover a little bit later that we also have a few replacement products available for the membranes that's currently in the market. So good performance declarations directly from our customers. Also something to show that we have real world validations of how our technology is performing, which is important for us and I believe also for our customers. And these declarations just confirm that our technology is reliable and also robust. I just wanted to mention that we do have confirmation directly from our customers that our membranes are performing. So just an overview of where we apply our ultrafiltration membranes. Oops, sorry, this one is automated, so I hope it will stay here now. But water reuse in a poultry processing plant in Central Europe. So our membranes are applied after sand filter, just before reverse osmosis, and I believe this water is then being reused in the factory again. Here we use our WMC200 UF 150, so 150 kilodalton membranes. There's 4 skids, 40 modules per skid, and the membranes have been operating for more than 6 years. So fluxes of 40 to 50 LMH has been reached. RO pretreatment, so seawater desalination. This is in Saudi Arabia. So at the port of Jeddah in Saudi, we have a customer, Kandasa Water Services, that was also one of the good performance declarations which I've shown earlier, and this is to treat the seawater from the Red Sea. There we've got 880 modules installed, and that's the HydroCap 60, which you might be familiar with from the hydronautics range. So system configuration, again, 10 skids, 88 modules, and our first replacement was in 2021. High recoveries of 90 to 92%, and this is also just before reverse osmosis, more than 4 years. Then a seawater desalination plant again in India. So, sorry. Also 30 skids, 120 modules, and here we've got one of our most recent developments of ultrafiltration membranes installed, 55 square meters, and that's also UF 150. We're operating at fluxes of 80 LMH and reaching an SDI of less than 1. So again, lamella calorifier, disc filters, ultrafiltration, and then reverse osmosis. So like I've mentioned, we can replace our membranes cost effectively with one-on-one replacement. It's a technical fit with most of the membranes that's currently in the market, and our membranes can fit GE, Penta, DuPont, Inga, Hydronautics, and also VWS. So we do, in cases where we do need adapters, we do have those available. So we can do a retrofit, or we can assist with a retrofit to your needs. Our membranes can be, all of our membranes are backwashable, and the normal CIP and cleaning ways are acceptable. And then just to give an overview of all our water membranes, so it's including the nanofiltration here and the ultrafiltration. So the two modules on the left-hand side of the screen is your nanofiltration, and all to the right is your ultrafiltration membranes. So there you can see that the ultrafiltration also goes from anything from 15 square meters up to our latest development, 65 meters squared. So I believe if you would like to discuss any replacement projects or so, I'm more than happy to discuss that further. And then should you want to develop a membrane project with NX filtration, we do application feasibility checks within our sales engineering team. Also, we have our own in-house projection software, so we usually assist with that also. We do assist with full-scale system design, so should you need any information from us or need assistance with checking PNIDs, we do have those. We do have those expertise within our team. And then we can also assist with startup and commissioning of your plants. So just to recap, I mentioned a little bit the unique features of HFNF and the main application areas, which is your surface water and wastewater treatment, as well as UF applications and retrofitting capabilities, our membrane portfolio, and how you can develop your project along with us. I think in the end, we've all got one mission, and that is our motto at NX Filtration, is clean and affordable water for all. So, thank you.
Issues with PFAS may not have a problem. What do you mean by that? And what membrane material? I'm assuming it's something to do with the manufacture and the material of the membrane itself. That's when it's not PES. But yeah, maybe you can just talk about that statement a little bit.
Yeah, thanks for the question, Rob. So basically, the PVDF manufacturing of PVDF membranes would become a regulation eventually, where PVDF would fall under that under the PFAS regulations or the micropollutant regulations, and that is where we are already covered. And from a manufacturing point of view, to be all right with continuing our manufacturing.
So does that mean that people making PVDF membranes? I mean, it's kind of bizarre. You're making membranes to treat water that are causing a PFAS problem. Is the PVDF manufacturing is using PFAS material? Is that what?
Yeah, that is it.
I didn't know this. I learned something today. Okay, thank you.
Thanks, Rob.
You mentioned that you don't require chemicals for the process, but with nanofiltration systems, you generally do find that there is a scale challenge. So I'm wondering how this system is managing that challenge.
Yeah, thank you. So in some cases, we do see that there would be an anti-scalant requirement, and then we would recommend an anti-scalant. Oh, well, we wouldn't recommend the anti-scalant, but we would recommend the customer to use an anti-scalant. But in most cases where we see that there's no anti-scalant or that there's no scaling, how do you say, no scaling warnings coming up in our projections, we would be comfortable with running without an anti-scalant.
And on the PFAS side, PFAS is a very broad kind of term because it covers an awful lot of different substances. How selective is 100% all PFAS is rejected, or there is some passage depending on the species?
No, so in some cases, well, for PFAS, we would recommend our more tighter membrane, which is the DNF40, and that would remove up to 80% of your PFAS. So in some cases, you would need a second step to do polishing. And usually what we see then is, say, for instance, you do GAC. Your GAC might just last a bit longer also on the operational side.
Okay, I have one last question, if that's okay. Is there any tendency for PFAS to accumulate in the membrane itself and make the membrane also a requirement for disposal as a result of PFAS accumulation?
Not as far as I know, but as far as I know, it would all end up in your concentrate.
Thank you.
Thank you.
Yeah, thank you for the interesting presentation. My name is Bonginkosi Nyemba. I'm from ESCOM. So I'm more interested on the stats you shared earlier on. You mentioned that only 2% of wastewater is actually reused in Europe. I mean, why is that the case? Because I thought we were encouraging wastewater treatment and reuse.
As far as I know, I don't know why that is specifically the case. I think we've got enough water so far still in Europe to not having to look at wastewater reuse. But yeah, that's as far as I know.
So I think in South Africa, we can teach Europe quite a lot about wastewater reuse because we do that a lot. Thank you.
I agree.
Thank you so much. I just wanted to make up a follow-up question from the good Mr. there. So when we talk about PFAS, do you have any idea of how many you have actually investigated so far? Because I think most of the time when we talk about PFAS, we look mainly into the likes of PFOA and PFOS as well as PFBA, while in an actual sense, given the extensive list of PFAS that we have, we tend to ignore the other ones which actually have been reported to cause the same effects and all that. So do you have any idea of the list that you have tested for?
We do have some studies where that information is available, so perhaps we can share that information with you.
Okay.
But I do not have that on hand at the moment. Sorry.
All right. Thank you.
Thank you.
Thanks, Loreen. Next, we have Masamo Sharma and Mohammed Al Homzi joining us from Danfoss. Welcome, gents.
Good morning. Good morning, everyone. So my name is Muhammad Ali. I'm heading the sales for TMA, Turkey, Middle East, Africa, from Danfoss high pressure pump segment.
And my name is Amok Sharma. I'm Global Application Marketing Manager for water reuse application for Danfoss high pressure pumps based out of Denmark.
So first, thank you, Marsi team, for the whole week. I mean, pleasure to be here with you. Mr. Pierre, thank you so much for everything this week. Just to make it a bit interaction, so we will start with a question for you, Amog.
Yeah. So, I mean, this whole week has been great, and we have eaten a lot of meat, a lot of burgers. So, a question, all of you: how many liters of water does it require to make a hamburger? Anyone? Yeah.
Yeah.
Anyone else?
Yeah. Huh?
So, so it's 3,140 liters. Yeah, a lot.
So yeah,
And most of it taken by the beef patty.
the beef, yeah, bun,
Yeah.
lettuce, tomato, cheese, bacon. If we need to add bacon, so yeah, it's
And this reminds, the water stays. We had a great conversation with peers, I think 2 days back, where we discussed that water stays there. It's not evaporating. It's not going anywhere. It's on the earth. But we ourselves are reducing the available fresh water. And that's why we all here as well.
Yeah. So we will go through a bit about overview on Danfoss group overall, and then a bit we will touch on the product side. So Danfoss is the leading technology partner for the green transition. So our key focus is desalination, water reuse, and industrial water. We do manufacture high pressure pumps and energy recovery devices. And from our experience, we have up to 29,000 SWRO worldwide for water reuse and seawater RO application. So about Danfoss, we are a group of more than 39,000 employees located worldwide in all the continents, and our global sales around 9.7 billion euro. And that's the whole segment. I mean, and Danfoss still is a family-owned business with the third generation in Denmark. We cover the whole continent, Americas, Europe, and Asia, and our most sales is coming from Europe. The business segments for Danfoss, we have power solutions, we have climate solution, and the drives. So the contribution of each segments in percentage here, and we are part as a Danfoss high pressure pump under the umbrella of climate solutions. On our application or our customers globally, so we deal in desalination, water reuse, humidification, flat panel cleaning, firefighting, and gas turbine. It is based on the axial piston pump technology. And from application to application, just we have some differences in the material. Our APP, we call it our axial piston pump for the high pressure pump. And we have our ERD, we call it iSave, energy recovery device. It is a device, ERD, motor, and booster pump in one body. And we have the active pressure exchanger. It's also, we call it motorized pressure exchanger, ERD plus motor. So our APP, which is the axial piston pump, we can see in the picture here, we have a pump on positive displacement technology. In efficiency, up to 92%, 90% or 89% minimum at any point. It's a simple design pump and easy to use. It's made of duplex, super duplex, and in most of the cases, we have it in fully super duplex material. And the range of the APP, we can start from 0.6 meter cube per hour up to 92 meter cube per hour as a single pump. So some improvement on our pump. We call it the ceramic pump. So we have some improvement. We change the peak material to ceramic pumps, and then we like that we can save in terms of pre-treatment cartridges. So some improvement. What happened in here that we can use the pre-filtration with 5 micron nominal standard standard filtration and a longer service interval. So our basic pump or standard pump, it's up to 8,000 hours. And then now we double it to 16,000 hours by changing some of the components from PEEK to ceramic material. Maybe we can see the next page. So, want to add something on the ceramic?
So we are very proud of this, first of all, because it's an award-winning pump as well. We won an award in EDS 2 years back, and since then we have around more than 50 installations worldwide so far for both desalination and water reuse. Coming back to this point, so the key parts, the valve plate, the port plate, and the source plate, that are the major wear parts of the axial piston pump, are changed into ceramic components. And the pistons are hardened, so it is perfect for the, especially a very demanding harsh water, especially when it comes to water, industrial wastewater, and it's also available in different ceilings to accommodate that harsh water conditions.
So a question also here, and how we need to jump to what value we are adding in the let's say water treatment business, especially when it comes to the high pressure pumps, and what is the difference between our axial piston pump and the centrifugal pump? So next for you, Gamok, also.
So normally what we have seen, when we are designing our plants, our systems, we are looking at this different, pressure, flow, and whatnot. And, we design it, and then we based on that, we choose the actual or the pump and the energy recovery device. But those conditions are constant, but the world is not constant. So the key benefit that you get with an axial piston pump compared to a conventional centrifugal pump is consistent high energy efficiency across the flow, the flow, irrespective of the flow and the pressure change. So the efficiency is independent of the flow and pressure, and you don't need to have any extra comfort margins in the system curve, and you can design your system without worrying on looking at the best efficiency point for the centrifugal pump. So and you can just design it, and that gives you design and operational flexibility as well.
So an example, if we are designing a 10 meter cube per hour flow on 10 bar, we can get the 10 meter cube per hour, and on 80 bar we can also get the same flow. So it depended axial piston.
Yeah. So this is what we have seen for one of the example. This plant has been running for 4 years already, and there has been a lot of flow and pressure variance, but the efficiency on the has been constant. That has been 91.6% there. And this is what we have learned from our customers, end users, that the key value that they or that what they value the most is the highest efficiency, because that not only reduces the cost, but also reduces for the end users the CO2 emissions, which is also contributing to meeting their climate goals. So as I said, so the more everything is constant when we are designing in a static. The electricity price, the permeate production recovery rate, and the seawater temperature. But in the real world, the world is not static, because the membrane pressure is changing across the season. There are daily electricity price variation because of the geopolitical situation as well. And the water demand variation is also changing depending on the rainfall or how much water they want to produce. But this impacts the total system efficiency. So here we have, based on these two scenarios, a static and a variable, we will show just a quick on what are the impact on the savings that you can have with the axial piston pump compared to the centrifugal pump. So when you see from train size to 500 to 10,000 CMD plant, if you look at the constant condition, that is the brighter red, you'll see you have a lower savings, or in other words, in the static, in the variable changing world, you see even more savings of cost versus the conventional technology of centrifugal pump when you use an axial piston pump, because the energy efficiency remains constant irrespective of the flow and the pressure or any of these external factors. So, Homsi, you want to?
Yeah. So just back to the APP or the axial piston pump that we have it. I mean, in here we can see the easy disassemble for the pump and how we maintain the pump in the regular maintenance. So in here we can see the pistons and the spring cartridges and again the assembly where we have it. So it's a few moving parts and really a small footprints for the SWROs or the plants, even in containerized or land based. And then the easy to service. I mean, on site it take few hours, and Derek here also he can he have the most experience on our pump on site. You're smiling, so it's easy or it's a hard one? Easy one. Yeah. So yeah. So in conclusion, I mean, we have a value in our pump in this, and we're coming with a 30 or 35 years experience. Our pump is made in Denmark, our one factory in Nordborg, near the HQ, Danfoss HQ, and we always speak efficiency in pumps. And then next we will see the ERD, what we've been talking about. So we have two type of ERD. The first one, the iSave, and it's a patent technology from 2008. And the first field application was in 2009. If we need just to give you an idea, our iSave mostly for containerized application, more or less. And then we can start from 200 meter cube per day plant until 3,000 meter cube per day, which we can fit the APP pump plus the iSave. And when we spoke larger systems, we prefer to go with the motorized pressure exchanger. So the booster will be separated. It's the same device, but we remove the booster pump from the iSave, and then it will be separately like a isobaric system. And we have more than 15 years in experience and 3,000 worldwide references with our ERDs. So the models for the iSave, we have 4 models. And it depends on the reject flow that we have it. So iSave 21, it is a 21 meter cube per hour reject. And then up to iSave 70. It's a fully super duplex material on the high pressure and wetted part. And as you can see here, pressure exchanger, the booster pump, and the electrical motor. And it is a VFD driven. So it's an integrated solution. I mean, 3-in-1, compact. It can be installed horizontal and vertical for saving for the footprint. I mean, how the iSave work, we will not go a lot in detail, technical, but that's a device that it can get the brine or the high concentrated flow into a pressure exchanger, and then we pump it back to the same line, so we can save up to 50 to 60% of the power consumption the SWRO plant. So just a comparison, because in the market we have the isobaric pressure exchanger, and on the left side we are seeing the iSafe. So in here we can see more component needed as a pressure exchanger, motor, the super duplex material, and the high pressure flow meter. And if you compare it to our iSafe, it's a one product. It can replace the whole set on the right side. That's an idea about the motorized pressure exchanger. Typically the same in terms of efficiency, in terms of material of the iSafe, but motorized without a booster pump. And that's we use it again for the larger system. In the MPE 70 or iSafe 70, we prefer to have the motorized side to have the benefits for you on the market on the control. It's purely a control based, VFD driven, protecting your system. And in terms of material, it's a super duplex material.
So just before we go to the next slide, a question or sort of something for you, Homzi. We have up to 92 cubic meter. So what if you want to go for the mega plants, like in the region, especially which you are handling?
Yeah.
How would you?
So instead we have a limitation in our pump up to 92 meter cube per hour. When it comes to larger system, we design our system to go with parallel systems in terms of pumps, and this will give you a lot of benefits in terms of let's say we call it no pump, no water. So when you have two parallel pumps, I mean, you can cover your system, and you have a compact design more to control the efficiency and the design. So in here we can see two examples. In the first one, a centrifugal pump plus booster plus the pressure exchanger. In here we have a 1,200 meter cube per day to 2,000 meter cube per day. We can see a single pump plus two iSafes, and the footprint is dramatically saved in here. I mean, the example next, maybe, yeah.
To add, so when we have more parallel pumps, 2 to 3 or 4, so this also gives the flexibility of whenever you want to have less water, or if one of the pumps gets, there's a unforeseen situation and it's not working, but then you have the other pumps to work. Whereas in the centrifugal pump, once the pump is down, then you have to either repair it or change it. So you lose that hours of production of permeate that you really need. And this is just an example of this train size of 5,300 cubic meter per day, where 3 APP pump with 4 iSafe 70 can be installed. But you can, of course, the beauty about our products is that they are compact. So you can fit it in a container, and you can actually, if you want, let's say, more water, you can add extra modules. So you don't need so much of infrastructure to build. Rather, you can have containerized systems where you can just add it just like Lego. So yeah.
And that's a 16,000 meter cube per day. So per train is around 5,000. And just at the end, we have a 4 core technologies that it can support you in the design of the plants. So we have pumps, ERDs, variable frequency drives, and the sensing solution. So it's a 4 core technology that we can really be a partner for you in the design stage. So in time's up,
Yeah.
but thank you so much.
Thank you so much.
Good morning. My name is Paul Reulen. First of all, thank you very much, Pierre, Marius, also Derek, for the invitation. Also, we enjoyed this week very much. I think I'm from Kurita. I think I want to connect to what Laureen was starting with we are all talking about sustainability and water savings and energy savings, and many are talking about it, but are we also doing something about this? That's another story. So I think Kurita is priding itself into continuously trying to innovate our chemical products to try to achieve the sustainability targets of our customers. Because nowadays everybody is trying to save water, everybody is trying to save energy, everybody is trying to reduce CO2 consumption or production, but not everybody knows how to do this. And we are continuously putting effort into our research and development to innovate our products to be able to achieve the sustainability goals of our customers. So today I want to share a little bit of the vision of my company with you, and I want to give you a few examples of products. Later on you will see we have more than 2,500 patents on product and product applications, so I would need a few years to explain them all to you, and I only have, even the time's up according to this one, so I don't know how much time I have left, but and you want maybe coffee at 10:15, but we are not going to make it. I need a little bit more time maybe. So I'll try to keep you awake during this time. First, so Kurita is a Japanese water treatment company. We were established in 1949. Water treatment is our core business. We are not doing anything else. So we started as a boiler water manufacturer, then we continued in cooling water treatment, wastewater, and now we are a holistic provider of water treatment technologies. So from the intake all the way to effluent treatment, we can do everything that is done as applications in the industry. Yeah, so our vision is pioneering new value for water to contribute to the realization of a sustainable society. It is connecting to water availability. Laureen already mentioned it. The World Health Organization has said that in 2050, that 25% of people have no access to drinking water. And we are taking it for granted because everybody has a bottle of water in front of them. And you have not been thinking that where is it coming from, how was it produced, what it is cost, and we take it for granted. And I remember that the first time I came to Saudi Arabia, that is already 20 years ago, the water was 10 times more expensive than the fuel. Can you imagine? The fuel that time was 12 euro cents and the bottle of water was more than €1. So if you would ask somebody what's more valuable, oil or water, they would say, yeah, oil is very valuable. It depends where you live. So it is like this. And I think we have to be more conscious about these kinds of things because in many places, also in Europe, yes, we have a lot of water, but the water is being polluted and it's not so readily available anymore. And yes, we have to think on water reuse and recovery of wastewater. And our company is trying to play a role in those processes. So I'm not going to read out all these things are on the slides. You can read yourself, but I think the message is clear that we are trying to continuously innovate our products and product applications to achieve sustainability goals of our customers. Yes. So how do we do this? So first of all, we have 5 research and development centers globally. The first one is our new Kurita Innovation Hub, which is in Japan. It was established in 2022, but it's not the first R&D that we have. So you should not think that we started only doing R&D in 2022. We started already in 1952 in Yokohama, our first R&D. But every few years we upgrade the facility, and this is our new hub. My colleague Sigles had the privilege to go there, right? Was it good? You're still impressed. You're still quiet. Okay, good. So next one is in Singapore. We have also a technology center in Europe. We have one in the US, and the latest addition is a technology center in Saudi Arabia. Yeah, just a little bit about the numbers. So our annual sales is around $2.3 billion US dollars or euro. We have more than 7,000 employees in 110 countries. We spend 1.9% of our income in R&D, so 50 million euro we spend annually. We have more than 200 people in R&D over the 5 facilities. And as I said, we have more than 2,500 patents on product and product applications. I'm going to mention 5 or 6 of these technologies very, very shortly so that you get an idea of what we are doing. Yeah, we call it CSV, customer shared value. We want to create a situation where we apply our products and technologies that create a win-win-win situation. So if the customer can win because we can save water, energy, we can reduce total cost of operation. If Kurita can make some profit, we can reinvest this in R&D and innovate our products again. And the next winner is the environment, because if we can save water, we can save energy, then we don't have 40-degree temperatures in the Netherlands, right, Loreen? So it's going to be very hot. And then, Marius, we don't have so much rain anymore in Cape Town because sometimes it's very dry and now it's raining. And this is because we have climate change. And everybody who would deny this is a little bit ignorant. There's really many things are happening, and we are trying to play a role with this. So sustainable development goals that are set by the UN, we are trying to live with them and work with them and innovate our products to achieve all these goals that are set globally. So here's our portfolio: boiler water, cooling water, chillers, membrane treatment. My colleague Dan will later on in the case study talk more about RO, but also wastewater, cleaning, process chemicals for paper industry, steel industry, even drinking water and swimming pools. So everything holistic applications in water treatment. I'm going to mention, like I said, 5 or 6 different technologies, which are technologies that for sure can contribute to sustainability targets. I'm just going to give you a bird's eye view of these technologies. So first of all is a boiler water treatment chemical. It's called cetamine. Cetamine is a range of products that was established already a few decades ago. So how can cetamine help, let's say, our customers? So traditionally, boilers are treated with different chemicals, sometimes 3 or 4 chemicals. You have an oxygen scavenger, you have a phosphate for internal treatment, you have an amine or an amine mixture for your steam and condensate lines. And sometimes you also have even a dispersant if you have problems with, let's say, suspended solids or sludge formation in your boiler. So cetamine is a product range based on filming amines. It's a 1-drum product. So you only have 1 chemical that goes through your entire system. It is volatile, and it creates a very, very thin monomolecular film on the metal surface. And this goes through your entire system. So actually what it does, as you know, for corrosion phenomena, you need to have water, iron, and oxygen. So if you separate the iron from the water, there can be no corrosion. So the concept behind this technology is completely different. So once you add this in your boiler, your whole system will be protected. That's the concept behind this chemical. So it's easy to apply. It's very, very efficient in the use. And the biggest benefit is in the water and energy saving. This chemical does not contribute to conductivity in your water. The contribution is very, very minimal. So when you replace traditional conventional treatment with this chemical, you will see the conductivity sharply going down. When the conductivity goes down, you can reduce the blowdown settings of your boiler. When you reduce the blowdown of your boiler, you need less water. When you need less water, you need less energy. When you need less energy, you produce less CO2. It's very simple, right? So, but this is how it works. So it contributes heavily to water savings. There's a lot of other benefits connected to this cetamine. For example, it's a chemical that is stable under dry and stagnant conditions. So even if you shut down your boiler, you can still be protected for 3, 4, 5, 6 months. So no special layout procedures. Iron transport will be reduced even when you start up after 6 months. Heat transfer is going to improve. It has been proven that the magnetite layer on the protective layer on the metal is reduced and more thin. So heat exchange is improved also. So it has a lot of benefits. We have more than 5,000 boilers on this technology, from low pressure, 2 bar, 3 bar, up to very high pressure, 200 bar. So it's not a one product, it's a product range. We select this product based on the pressure. And in addition, we also have products that have a direct food allowance. So it can be used in direct contact with food. except in the dairy industry, because milk products actually react with the cetamine, so we cannot use it in direct contact with milk products, but in all other industries it can be used in direct contact. The second one is also for a boiler. This is called a dream polymer. And the reason why this product was developed is that in this world there's a lot of low pressure boilers that are being fed with softened water, and 80% of these softeners have a problem. So all of these boilers are creating a scaling problem, and then the go-to idea is to descale using an acid. So you would use an acid to descale, and again the softener doesn't work, so you do an acid cleaning again, and you do it every month. And I see it especially in East Africa. 99% of low pressure boilers have a scaling problem, and they use more citric acid than they use an antiscalant. So the antiscalant, of course, doesn't work if your softener is not working. And this dream polymer was established as a replacement of that process. And the dream polymer is a polymer that can be formulated even with the cetamine that cleans your boiler online. So you don't have to take it offline and clean it with an acid. It cleans it actually online. Depending on the thickness, it can take a few weeks, it can take a few months, but finally it cleans up the boiler completely from any scale. It can be calcium carbonate, can be silicates, can be magnesium minerals, but finally it will clean it up completely. And the cleaning process is done by actually redissolving the scale. So it stops the use of acid, it stops the discharge. So again, this is connected to sustainability, because if you use acid and you throw it away, it's very difficult to get rid of this in the environment. So this is helping a lot to improve the operation of the boiler. Of course, also it is very efficient for your energy, because if you have even a small layer of a scale, it contributes to much more use of energy. And energy cost in the boiler is your highest cost. It's not the water, it's not the chemical, it's the energy that you spend. Okay, I have to rephrase a little bit, because in East Africa they use biomass and wood and macadamia shells, etc. So it's not so expensive as if you use gas and coal, but it will definitely save you on energy and CO2 production. This is a patented product, by the way, this one. Yeah, just we have many of these case studies, and you can see the difference between before and after. So sometimes it takes a few weeks, can take a few months, sometimes it can take even a year if the layer is very thick, but you don't have to do an offline cleaning anymore. You can keep on running, and the scale will be removed, and it will be prevented over time. Yes, also to connect to the Danfoss guys, this one is also awarded, okay, this one, awarded chemical. Then for cooling water, Dilrit BCS. Dilrit BCS is a in situ biocide system. This chemical technology was created as a replacement of chlorination. Maybe in Africa, the discharge regulations for chlorine are not as severe as they are in Europe. But in Europe, there's nowadays, most countries have a limitation of free chlorine of 0.1 in the discharge. And 0.1 ppm of free chlorine is not enough to sterilize your cooling water. So we found a replacement, which is called Dilrit BCS. This system creates a monochloramine, and monochloramine has many advantages over traditional chlorination. And I think in the next slide it is explained. It's a little bit small, but so it's an in situ biocide generated. It has a much lower oxidation potential, so the corrosion phenomena coming from this biocide are much less. There's no bromine inside. Bromine is much more toxic, and also it has many restrictions. It can save you water because it doesn't decompose to chlorides, and chlorides again contribute to corrosion phenomena. It has almost no AOX, so almost no free chlorine is coming from this product. It's easy to monitor with the total chlorine analyzer. It has a lower carbon footprint because the BCS actually has the power to penetrate into biofilm much more than chlorine does. So when you can remove biofilm from the packing of your cooling tower, you need less energy to pull the air through. So it creates energy efficiency. And again, it's reducing CO2 production. Yeah, I think those are the main features. It is used in cooling water in the industry, but it's also used in the paper manufacturing industry, in the paper machines, this kinds of technology, because slime formation is very common in paper manufacturing, and this kinds of technology is much better than chlorine. Chlorine would also cause breakage of paper due to the oxidation power and leaching of the calcium from the paper. So this technology is also very valuable for the pulp and paper industry. Next one, free technology. This is again also for cooling water. This development was a bit of a coincidence. We were trying to find out if we can also use filming amines for open cooling water systems. And this is a topic because a filming amine is food for bacteria because it contains nitrogen, and we were trying to find out how much does it decompose when you use it in an open cooling water system. Finally, we saw when we were applying certain types of filming amines, so it is derived from the cetamine brand basically. When we started to add filming amines into the cooling tower, we could see that it is starting to clean up the packing material. So the packing in a cooling tower most of the time has fouling. It has inorganic materials, organic materials, they're combined, and finally they plug it, and there's not a real way to clean it. The only thing you can do is replace the whole packing and put a new one, but then due to the very high, let's say, evaporation in your packing material, you get more scaling, you get again biofouling, and you cannot remove it actually. And we found out that this product can actually remove it online. So you don't have to replace your packing, it will actually clean it up nicely. And because it's a filming amine, it's creating a certain layer on your packing material that prevents, again, scaling and biofouling from happening. So it is very nice, especially in cooling towers that are generating this fouling, maybe because of high evaporation rate or high biological contaminations. And yeah, it was a little bit of a coincidence, but absolutely brilliant product. Yeah, you can imagine that also it will contribute to lower, let's say, energy consumption, because if the flow of the air through the packing, you need less energy for the fan to create this. And yeah, we have different case studies for this that we could share. Basically, let's say if it can remove biofilm, it will really also reduce the, let's say, scaling tendency in the packing. So to keep it clean, so BCS together with this free technology is a brilliant way to prevent biological contaminations. Next one is CoreSafe. This is again a patented product. As some of you may know, cooling water treatment, corrosion inhibition is traditionally done with zinc and phosphate. But zinc and phosphate are, let's say, environmentally polluting. So we have been trying to find a way to replace the zinc and the phosphate. And we developed a polymer, which is called CoreSafe. It's a biodegradable polymer that actually has even better corrosion characteristics and anti-scaling characteristics than zinc and phosphate or phosphonates together. So it's environmentally friendly. So in this case, it's actually the impact on the environment is reduced and the performance is the same. So this one is very simple to explain, basically. And this also, of course, it's contributing because in many countries there are limitations of zinc discharge and phosphorus discharge. So if you have such limitations, this product can help to achieve your discharge regulations. Again, there are many different products that are containing this product. There's different case studies on this. So with less phosphate and less zinc, you achieve better corrosion inhibition, and it's biodegradable. Yeah, sometimes I see in tenders that they are asking for environmentally friendly biocide. It's a very interesting request, just as a as a side step. So this one is really environmentally friendly, yeah. Okay, membrane systems. Dan is going to talk more about membrane systems, but I didn't want to skip this chemical. Traditionally, biological contaminations are treated by using chlorine in front of the RO, and then you use SMBS to neutralize this. But unfortunately, this system is not perfect, so there's always a little bit of chlorine going to the membrane. You will get some oxidation, and then at a certain point, you have to exchange your membranes. And in addition, chlorine cannot penetrate into biofilm. It has been proven that it cannot. So if you have biofilm, the chlorine might be able to kill the top layer, but it cannot fully penetrate and release it. So the Kurita IK110 and 220 products, they were established actually to do this. This is also a patented product. It has been proven it can penetrate into biofilm and actually release it from the surface. So it will significantly increase the run length of your membranes. And the good thing is that you don't need to neutralize this. So you can enter this into the intake of your RO system. It can go all the way to your membrane, and it will actually remove also the biofilm from your membrane. It will be rejected. And this also is the first online biocide with an NSF certification. So it can be used in drinking water preparation, especially when you have a high biological load. This is absolutely brilliant product to remove the biofilm and to keep it clean. Your run length between CIPs will significantly increase. So you can imagine what are the savings. Of course, a lot of energy savings because you need less energy input in your pumps, and your flux will remain stable. So this is absolutely, again, a brilliant product. I see my time is up, but I still have a few slides. So I think you give me 5 more minutes. Then I give you coffee if you wait 5 more minutes, yeah? So yeah, it is a very easy to use chemical. You don't need to neutralize it or anything. Just you feed it on the intake. It goes all through your system. And finally, you will see that membrane replacement is going down. Your chemical cost goes up. So your chemical goes up, but all the other costs, energy cost, replacement cost, CIP chemicals use also will go down. So finally, again, it's contributing to sustainability. Yeah? We have less CO2 production, etc., etc. And finally, we can achieve savings. Here is an example, 20% on your total operational cost using this product. So you're shifting the cost a little bit, but at the end, you're saving money. Wastewater. So sensing CS, this is a device. So I think everybody who is working with wastewater treatment knows that if you have fluctuating influent or effluent water, you need to do a jar test every day, every 2 days, every week, 3 times per day. And you need to jar test, and then you find out what is the best dosage, and then you go to the pump and you set the pump. And then the pump is running, but your influent or effluent is changing again. Again, jar test. So this sensing CS is a device. It's a laser-based device, so it's a small probe that sends a laser signal into your influent or sedimentation tank, and it's measuring the turbidity between the flocks. Because when you use a flocculant, you want flocks to be created. You don't want turbidity. So the lower the turbidity, the better it is. And this device you can connect to the dosing pump of your flocculant. So it's continuously measuring the turbidity between the flocks and continuously adjusting the dosing of your flocculant. So it's an automatic jar test. And you do not have to do jar testing anymore. And it has been proven realistically that we can save 20 to 40% of the chemical dosage, chemical consumption. And no, our goal in our company is not to sell you more chemical, is to sell you less chemical with higher profit. You can understand why. Because then, again, we can invest in research and development and innovate our products again. But we both win. Environment wins, customer wins, Kurita wins. So very interesting device. I see I have to go a little bit faster. This one I can do very quick. Kurita Connect 360 is it's a web-based online platform for, let's say, data collection and reporting. And we are connecting our, let's say, monitoring devices to the internet with a SIM card or something. And the customer can log into the website and they can see what's going on. They can see the reports. So it's just a web-based system to connect data to the customer. Okay, I'm almost done. So yeah, besides chemicals and innovations on products and technologies, we also develop equipment. So there are several mentioned here: hydrobio, Kurita, sensing for the different kinds of systems. We believe that, as I said, our goal is not to sell more chemical, it's to make the application more efficient. And for this, we apply AI and we apply all these kinds of equipments, and we keep on innovating these monitoring devices also to make sure that we can achieve even higher targets and goals of the sustainability that our customers are looking for. I think this is my last slide. Yes. I'm sorry I used 32 minutes instead of 25, but at least now you get the coffee very quickly. Is there any questions or? Yes.
Thank you so much for an interesting presentation. My question is on the diluent.
Yes, diluent, yes.
VCS. Does it also work best for targeting antibacterial resistant bacteria? Anti-resistant bacteria.
You're talking about resistance of bacteria against biocides.
Yes.
Yeah, that's a little bit of a topic, and there's a lot of misunderstanding on this topic. I think there is a certain species of bacteria that can get resistant against certain biocides, but in general not against oxidizing biocides. Basically, because the way how the biocide works against the bacteria is different. So bacteria need water to live, and most of the chlorine kinds of biocides have a similar molecular structure than water. So the bacteria doesn't recognize it's water or it's a biocide. So also for this monochloramines, they cannot grow any resistance, because even it's not our goal to kill bacteria. Our goal is to remove the biofilm. So the bacteria is, let's say, aerobic bacteria are generating biofilm to protect themselves, but we just, let's say, dissolve the biofilm so that it releases the bacteria and it is rejected. So our goal is not to get a high ORP or a high oxidation power to kill them. The idea behind the technology is to remove it before they become active. And they are not really killed, they are more deactivated, so they stop multiplying. That's the idea behind this diluted BCS system.
Okay, thank you.
Yeah.
Your online laser monitoring jar test replacement machine, yeah. Sounds like it's targeting drinking water, relatively low solids applications. Can it also be applied in like high solids, like DAF systems in industrial applications where you've got lots of flux, lots of solids?
It's a good question. There is a limitation in turbidity. I'm not exactly sure, but I think something like 200 to 300 NTU is the limit where it functions well. You understand it right. Of course, when you have a lot of turbidity in the water, the laser beam gets completely distracted, and then you don't get a signal back. So it's completely absorbed.
Yes,
so
cool, yeah.
When it's highly contaminated, I don't think it will work properly. Yes, correct.
I'm interested in the free system that you talked about, the online cleaning, So you mentioned that there was a 20% saving on water, makeup water, right?
Oh, you mean the first product I showed, the cetamine?
Yeah, for the main, for the main cooling water system,
Which product was that?
Free. We call it free. Free?
Free. Was it?
So you showed a cooling tower there.
This one?
Just before this one. Yes, this one. So the water savings there, you mentioned the 20%, saving.
Yes.
Yeah. So what cycles of concentration were they running at before you installed this system, and what did they achieve afterwards in terms of cycles?
Yeah. The let's say what happens in many cases, if you have fouling if you have high fouling in your cooling water systems, you normally have to blow down more, right? But if you can prevent it from sticking everywhere in a certain way, then most of the time you can increase your cycles of concentration, because the risk of deposition is reduced when you catch it as a dispersant and move it in the blowdown. So then you can actually increase it. It's about the dispersing power that you create that might increase the cycles of concentration. That's the idea behind it.
But in terms of a case study, do you have the actual figure?
Yeah, we can provide you some more details and case studies and
I
these
would like
kinds of
to see
things.
that
Yeah.
because we run at high cycles of concentration in our power plants in Eskom
Okay.
in an effort to conserve water, but we do have issues with scaling and fouling. So yeah, I'll be interested to see that.
Yeah.
Thanks.
Okay. Thank you. Everybody wants some coffee now, I think. Eh? Yeah. Anyway, thank you very much for listening. Appreciate your time. Thank you.
Hope that was some good coffee. Hope you enjoyed that. So the next 3 presentations, they will all be real-world applications, things that are being seen around the world, and hopefully have application to what you're seeing in your consulting or your actual plants. So yeah, we'll kick off with Dan Freeman from Kurita. And I'm actually looking forward to this quite a bit, cracking the code, some CSI-styled presentation. So yeah, Dan, we're looking forward to this. Thanks.
Okay. Thanks, Derek. Hello, everyone. My name's Dan Freeman. I am the product manager for Kurita's membrane treatment chemical solutions. My job is to manage the product line, to be a technical contact for our sales team, and also attended functions like this to demonstrate some of our products. Today, I'm going to talk through a few case studies, actually more than one case study. I'm going to go through a series of case studies whereby I will demonstrate some of the benefits of our approach to membrane systems, how we tackle problems that we see on membrane systems, and use the information that we develop to provide solutions for our customers. So, okay, reverse osmosis. It's been around for a long time. It's a process that we have seen for more than 40 years now. It's the dominant process for desalination. It's extremely widespread use in industry, and it's also increasingly used in wastewater treatment. The main issue, or the thing that you need to be careful of when operating these systems is, of course, maintaining the condition of the membranes. And we know that when you get water on the membranes, there's always the potential for either contamination, accumulation of materials on the membrane surface, things that can damage the membrane. And when you accumulate materials on the membrane surface, you have the potential for issues with the operation. In particular, things like having to clean regularly, which means consumption of water. We're having energy issues. If you accumulate materials on the membrane surface, it becomes less efficient. You have the potential for damage of the membrane, a permanent performance loss because of particular foulants. And all of these things can contribute to CO2 contribution in terms of CO2 usage. And of course, they all cost money. So these are all issues that we need to be aware of. Having said that, all these things come in with the feed water. It's obvious that when we see a problem on an RO system, we need to work back through the system and understand where and why the problem occurs. So we go through a particular process. It's an investigative process. We want to understand each element of the system. We want to understand what's performing well and where we can improve the system, either in terms of a chemical change, a dose rate change, maybe in some cases just a change in the operation in order to improve the system. It's an investigative approach. And what I'm going to do today is talk about one of the tools we have in our locker for understanding what issues an operator may have with their particular system. I'm going to talk about autopsies and how we use an autopsy in order to identify issues with the system and correct those issues. An autopsy is an approach where we take an element that's fouled or damaged in some way, we break it open, we take a look at the membrane surface, and we can make an understand what is the best. In fact, is the best way to really understand what's going on with the membrane. We can see exactly what's on the surface. We can see quite a lot of the history of the membrane from an autopsy. We can also see if there are multiple issues. And in fact, most cases, I would say, there is more than one issue with an RO membrane when we break it open and have a look. And you can see what exactly is there. One of the most useful techniques that we have in the autopsy is what we call chromatic elemental imaging. So you can see the colorful image there in the center of the screen. That's a kind of technique, an advanced technique similar to SEM microscopy, where we can look at the membrane surface and understand the distribution of elements across that surface. And that tells us a lot more, it gives us a lot more information in terms of what's on the membrane surface and how it's deposited. If you use a standard SEM image, it's a black and white image, it can tell you what elements are there usually, but we can't understand exactly how they're distributed. So one of the real benefits of that process is to understand how those are distributed. And in some cases, you can see different layers of distribution. So you can understand that there's been more than one event that's caused a problem. So what I'm going to do today then is go through a few of our autopsies, take a few cases from our list of autopsies and sort of explain how we go through this process and some of the benefits of it. Okay, so the first case then, it only takes a few minutes to look at the cartridge filters here to see what sort of issue we might be facing with this kind of system. And this extreme case where you can see that we have accumulation in the UF, we have accumulation on the cartridge filters, and then accumulation of material on the feed face of one of the membranes. When we open one of those membranes up, this is what we are seeing. And if you know anything if you've seen this kind of problem before, you even from the color, you're gonna have a good idea that this is going to be an iron problem. Iron problems are pretty common. And you can see that also when we take a look at the CEI image, we have iron present, but we also have a lot of calcium. Iron and calcium carbonate scale often precipitate as in common because the iron will actually deactivate the antiscalant. So if you have a lot of iron in the feed water and you don't account for that in your dose rate of the antiscalant, then you will often see that you see not only the iron precipitate, but calcium carbonate also. And that's what's happened in this case. This is a schematic of the system that this element came from. It's a well water source, and it's typical for a well water to have iron present as ferrous ions, soluble iron. And that's not a problem for the RO, actually. It's only when you bring it to the surface and it gets oxidized that iron can be a problem in terms of oxides of iron, ferric hydroxide, and these things that accumulate on the membrane surface. In this particular scheme, what the operator is trying to do is oxidize all of the iron that comes up with the water, give it enough residence time so that it precipitates, and then remove it with the ultrafiltration system. Obviously, when we looked at the ultrafiltration system, you can see that already it's pretty overloaded with iron. And so this system wasn't working. Basically, there's not enough residence time for the permanganate to oxidize the iron and remove all of it because it's passing through the system to the RO. And even if it does, the ultrafiltration system is struggling to cope with the amount of iron that's present. So what was the solution to this case? In fact, what they did in this case was to bypass nearly all the pre-treatment for the RO. Okay, and the idea here is that if you keep the iron in the soluble form as ferrous iron rather than ferric, then it will pass through the membrane system without precipitating. Okay, and it's not an issue for the antiscalant. So that's what they actually did in this system. The issue that you have to be very careful of when you're applying this kind of system is that if the iron oxidizes at the membrane surface, it will damage the membrane. There are intermediates in the process, in the oxidation process, free radicals, that will damage the membrane. So if we attempt to do this kind of process, bypassing the pre-treatment, we have to make sure that there is genuinely an anaerobic environment that passes all the way through the system. In terms of the cleaning of the membranes in the system, iron is a relatively easy material to remove. So in this case, we have a particular cleaner that's very effective at removing iron. So we're able to recover the membranes in the system, and by making this change to the situation to the pre-treatment, this system runs well. That's kind of an example of that. So this is our second case. This is a pretty unusual case. You don't see this kind of thing very often. But this is a case where the actual shell of the RO system, or the RO membranes in the system, has been damaged. And it's the result of using a very, very aggressive cleaner at a very high temperature. This kind of cleaner it's designed for silica removal. The operator believed they had a silica problem on their plant. The system wasn't running well, poor performance. And so they assumed it was silica, and they cleaned with this aggressive cleaner. And this is a pretty extreme case. You don't see this sort of thing very often, but of course, a high pH, very aggressive cleaner, and it's actually damaged the shell of the element. This is what that element looks like when you break it open, and you can see that, ironically enough, there is no real silica challenge in this membrane. So they used the wrong cleaner in any case. It wasn't the right cleaner for this particular problem. And I think that's something that you have to, the real benefit of an autopsy, of an investigative process, is to understand exactly what the problem is and to target target the problem with the right solution. And of course, in this case, not doing that has led to an issue. This kind of foulant, again, is iron, manganese, and calcium carbonate, particular problems. These things we can clean up. We were able to clean this system up pretty well. This is a CEI image from a different system, but had a similar problem. So on the right-hand side, you can see there's a dye test where we can see dye has passed through the membrane, and we can see that as an indication of damage. This element was damaged. When we actually look at the CEI, we can see that there are traces of calcium fluoride on the membrane surface. Calcium fluoride was not something that you would expect to see from the water analysis. It's actually a trace of the cleaner. So again, this is the same sort of cleaner. It's damaged the membrane, and it's left some traces. And you often see other things, other cleaners can cause, you can see on the CEI also. Sometimes you see where citric acid has been used for removing scale. Calcium citrate is not particularly soluble. So if you don't control the pH well when using citric acid, you can see that there's more of a problem. You actually precipitate a scale during the cleaning process. That's something else that we see quite often on the CEI. You wouldn't expect to see calcium citrate on a membrane surface. Also, there are certain limits in terms of what you can use in terms of surfactants. Many commonly used surfactants are a problem for RO membranes. So if you use the wrong cleaner, you can usually pick these things up on the CEI. The pre-treatment for the system that I showed earlier on with the damaged membrane elements was also a problem in terms of the same sorts of failures. And you can see here, these are the fibers for the UF fibers. We are able to recover those elements too. You often see with the UF fibers that material accumulates at the top and bottom of the bundle, because there's less agitation in the backwash and if there's an air scour. So you get an accumulation of these materials at the ends of the modules. If you can use a more formulated cleaner, which is more effective, you can get a better clean with that than you would generally expect to get with sodium hydroxide, for example, or an acid. In this case, we used a formulated cleaner, and we can see a big improvement in the performance of the module. Okay, when we see a membrane like this, it's pretty often the case that you have no chance of recovering something that's been as badly fouled as that. It doesn't mean to say that the element can't be of use. Okay, so we understand that there's a problem. We know that there's a precipitation or an accumulation issue on the membrane surface. We're going to throw this membrane away anyway. It's not going to be something we can recover, but let's open it up and take a look and see what the problem is inside. And here you can see very clearly that this is a scale issue, it's calcium sulfate scale. We cannot recover that element, but it tells us a couple of things. It tells us there's an issue with the antiscalant, or there has been an issue with the antiscalant, because if you're using the correct antiscalant, you shouldn't see scale form. It tells us what we need to do to clean whatever elements are still recoverable in the system. So we know now we can select a cleaner for that particular challenge. So even though that membrane's lost, we can still make use of the information that it tells us for that element, for that system. Okay, here's another case for a UF system. This is a UF that was not being recovered well with the current regime. They didn't understand exactly what the problem was. We were just using generic chemicals, and we took a look at the membrane. We looked under the microscope. We did a CEI of the surface, and we can see that there's a fairly mixed kind of deposit on the membrane surface. When you have a mixed deposit like this, we've got clays, we've got silica, we've got iron, we've got usually there's quite often organics on the membrane surface. When you get a mixed matrix like that, it can be very difficult with traditional solutions to get the membrane clean. So in this case, we used a proprietary liquid cleaner to remove the metals and the silicates, and improved a big improvement in the performance of the system. So we're going from 124% improvement in the flux of the system. This is another case where we looked at the membrane surface. This is a brand new system, not been in operation very long, and it's on a well. And what happened is the well wasn't well stabilized before they started up the system, and they were using drilling muds in order to drill the well. And what happened is they've contaminated the membrane on startup with material that's come directly from drilling the well. And that's a case of getting the membranes cleaned up, and then making sure that the wells run and stabilize before we actually start pushing for the RO. You can see there's a lot of silicate, aluminosilicates in this case. Cleaning it up with this kind of material, we can clean up with a proprietary cleaner. The idea here is to disperse what's on the membrane surface rather than dissolve generally. And in this case, we were able to make a very good recovery. You can see the cells in the center there. That's an actual piece of membrane taken from the element. We do a sort of test clean in the lab, and you can see that the performance of the cleaner visually, it's a very nice example, this, because it's a very visual result of an important clean. This is another system from a well, actually, another CEI from a well system. Again, you can see unusual contaminants here. These contaminants have come from the process upstream when they've drilled the well. So we've got titanium, which is a very unusual thing to see on most membranes, and other issues. Again, we were able to clean this particular system up with a proprietary cleaner. Okay, this is another situation that we see quite regularly, whereby you don't necessarily see a single problem on the membrane. Okay, in this case, we've got two different scales. We've got silica scale and we've got calcium carbonate scale. Now, those two scales require different treatments in order to recover the membrane. So we need to approach those two different problems in a different way in terms of cleaning. And once we can see what the issue is on the membrane surface, then obviously we have a better chance of cleaning the system up. And again, you can see we're able to recover this particular system very visually again with the cell tests. This is a UF system. It had a very, very, very low flux. But when we opened up the membrane module and looked at the membranes, there was not that much there to see. And it looked like, given the performance of the membrane, we were expecting much more material on the membrane surface. When we looked at the CEI, though, you can see that there is a very uniform, consistent layer of material on the membrane surface. And the primary failant in this case was barium sulfate. Barium sulfate is something that is relatively easy to clean off if you use the right cleaner. And we were able to recover this membrane. You can see an improvement, 818% improvement in the permeability after cleaning this membrane. So you can see how poor it was before we started and how we were actually able to recover this particular system. So just knowing exactly what's on the surface of the membrane is really valuable. To stop a lot of, you can spend a lot of time trying different things to try and recover a system, but actually taking a membrane out, looking at what's there, seeing what you're doing a test in the lab to see which is the best cleaner. Sometimes when you have multiple failants, it's actually the order that you apply different cleaners that's as important as anything. So it's like taking a membrane out and actually doing those experiments in the lab can be really valuable in terms of recovering the system. This is the last example, and this is a sort of contrast to the previous one. It's very clear that we have a problem on these membranes. You can see there's a lot of material on the membrane surface. Again, very poor flux, but by applying two cleaners in combination, we're able to address the issues here. The primary issue again is iron, also some silicates, although it's not so clear on this CEI. But again, we're able to recover the system, and we know what we need to do. Once we've done this autopsy, once we've looked at the membrane surface, we know what we are looking to do. Okay, so that's a small example of some of the autopsies that we have conducted. And we do about 350 autopsies a year in our global laboratories. That experience is where we get the basis of understanding what chemicals we need to apply. Also, when we're developing new chemicals, when we're looking for new solutions, it's a great database for us to be able to understand what challenges people are looking for, are facing with different waters. And it's really the basis of our experience comes from a lot of those autopsies that we're performing. Once we've done those autopsies and we go through our process of tests, we can usually recover most systems. There are occasions where there's something there that's very, very difficult to recover, and maybe it's particularly if the failant's too ingrained, then it can be difficult. But mostly everything comes off, and we're able to recover systems. And that basis of targeting the right cleaner for the right problem is really what this is about. Okay. I'll leave it there. I've got 3 minutes left, so there's enough time for a few questions. Anyone got any question?
Yeah, thank you. That was cool. I've never seen those surface pictures like that with color and
Yeah.
really, really interesting. Just a quick one. You showed that one of the images was that gypsum scaling on an RO, a calcium sulfate scale on an RO membrane.
Mm-hmm.
Have you also looked at, gypsum is a big issue in mine water in South Africa in particular, and a lot of the mine water plants are operating high recovery with anti-scalants, and then trying to precipitate the gypsum out of the brine, and then managing that in multiple processes, and in some cases going to thermal evaporators for the brine stream. Do you have experience with managing the precipitation of gypsum in thermal evaporator systems? Not so much so it's not an RO question.
It's a stairstream question. I don't actually, but that's something that we'd be interested to talk to you about, because I mean, really, that's a solution. If there are issues there, that's kind of our modus operandi, to go and see what the issue is and try and find a solution. And obviously, we have a lot of experience with that scopes, not just in membrane situations, but in cooling towers and so forth. It's one of our key technologies. So yeah, I mean, managing that sort of. But when you say managing, what's the function of the evaporator? It's presumably to completely remove the water, or is
correct. So these are approaching ZLD water systems, and ultimately trying to get all the water out of the brine stream that is generated in an RO.
So you're actually trying to precipitate the scale in that case.
It's a long conversation, but I'm just not aware of anti-scalant chemistry that's applied in these thermal systems. I'm interested to see if you have that experience. Yeah.
Okay. Anyone else?
Thank you for that insightful presentation. I just have a question with that one where you change the order, where you say you have a membrane first and then you take care of the iron afterwards. Are you not precipitating the iron afterwards? Where you said you are going to, you first have the RO system, and then you say you take care of the iron afterwards.
Okay.
So
further downstream, yes, that's a potential problem.
So you've got those. Basically, do a toxicity test to find out if you apply that to the environment, if it's okay.
Yeah, I mean, in that case, that's the system that was in the US. I'm not sure what actually was happening downstream of the RO system. Obviously, I'm focused on the membrane system, but yes, that's going to be a problem at some point further downstream. And how they manage that, I can't tell you to be honest at this moment in time. If you're interested, I can look into it though. But yeah.
And with regards to the membrane itself, do you also focus on particulate fouling, or you just looked into scaling and biofouling?
Any kind of fouling on the membrane.
Any kind of fouling, so you can use those chemicals and.
Yeah, we've got a range of different cleaners, so and they're targeted. So we're looking for things that will actually address each individual issue. I mean, they all have a reasonable profile against more than one potential problem, but there will be usually one where it's particularly useful. So we have one that's particularly good for metal ions. We have a cleaners that are particularly good for silica. We have cleaners that are particularly good for biofilm, depending on what the issue is. Yeah.
Okay, thank you.
Okay.
Thank you for the presentation. Very interesting. Any experience on oil-fouled membranes?
Yeah, oil can be a problem. We have cleaners that can address it to an extent, usually. But depends on how much oil is there and what kind of material it is. We have cleaned up some elements with specific cleaners, yeah. So it's something that we would, if you have a problem, in that case, it's definitely worth looking at an autopsy, and we can try different things and different solutions. Trying to do that on site is a difficult thing. We would need to know a little bit more about the problem.
Yeah, thank you.
Okay.
Thank you, Dan. That was interesting. That reminded me of my own personal favorite CSI is the Miami series, Lieutenant Horatio Caine. If I remember correctly, one of his famous one-liners was, "All that matters is the evidence." But hopefully we can prevent getting the evidence in the first place. I think that's actually the win. Next up, we'll have Amochen Mohammed taking us through applications on the high-pressure world.
So we'll show you some of the real case story from all over the world. And we'll start first about our global references. So about the land-based and the mobile containerized, we have around 19,000 around the world. scattered, of course, on the coastal sites, and we have around 9,000 to 10,000 in the marine and offshore installation as well in the ROs. So one of the challenges we will show you about a case in Canary Island with our customer Tagua. As we know, in Canary Island, we don't have any source of water, so only the sea. So it's quite challenge to get fresh water, and the energy is one of the, let's say, challenges faced by the clients there and the population. So we have been in collaboration with Tagua, how to optimize the system. They have some existing system and how really to optimize it in this. And in here, on the left side, we'll see an existing system with a turbocharger technology. And it's a SWRO plant with centrifugal pump, the turbocharger, and then they have the permeate and the brine. And here on the right side, what we design as a isobaric technology. So in here, we have the high pressure pump, and then feeding to the membrane the full pressure, and then by installing our ERD, which is the iSafe, which we explain it in the morning. So
just one thing before you go forward. Just wanted to say that Canary Islands is one of the places where one of the first desalination plants were installed because of their water demand requirement. And so this case story is about a retrofit project where they had initially used a centrifugal pump with a turbocharger, and the key challenge was to reduce the energy consumption and while producing the fresh water consistently.
So in here we will see a graph showing the cost of kilowatt hour per meter cube in on the left, and then we will show the old plants or the existing plants consumption per meter cube. So it was 4.48 meter cube per hour. Kilowatt hour per meter cube, and the production for this plant was 500 meter cube per day. As a preliminary design, what we design, we select a high pressure pumps replacing the axial piston pump, replacing the centrifugal pump, and a pressure exchanger, which is the iSafe installed vertical, also to replace the turbocharger in here. So, and the cost of electricity is around 0.15 euro per kilowatt hour. The design was on recovery rate around 40% and the TDS around 35,000 TPM. And by our calculation or preliminary design, we got 1.93 per kilowatt hour meter cube. And that's a huge saving. And if we need to talk about percentage, we save around 57% in energy cost for them, resulting in a 48,000 euro annual saving.
I just want to add one thing. On the right hand side, you see two photos: the plant with the existing the centrifugal pump and the turbocharger, and then retrofitted with the Danfoss equipment. So as we mentioned earlier in our presentation, that the specialty of one of the noble thing about our products is also the compactness. And when I started my career, I remember I was doing a lot of building the systems, and I used to tear my jeans a lot because of so many equipments here and there. This like 7-8 years back, and that's something that this picture shows, that on the above picture you literally have not so much space to walk around. When you retrofit with our products, you actually have much more cleaner space to walk around and to assemble, disassemble, do on-site maintenance, and so on and so forth. So it's much easier, not just in energy savings, but also the footprint. The amount of water produced per square meter is more when you look at our Danfoss technologies?
In here, so next, so resulting by a saving, and this is where we can show it on this graph, with comparing with what they have. So as a Danfoss system, we showed that the SEC, or the specific energy consumption, is around 1.93 kilowatt hour per meter cube, and for the existing one, around 4.48 kilowatt hour per meter cube. I mean, the payback time, it was in 2 months for this system once they start to retrofit. So what we can assure here that what we design, we have it on the ground, and what we execute. So we guarantee for the client to have this payback, and he got it in less than 2 months. In here, the cost of electricity, again, 0.15 euro per kilowatt hour. And on the right side, this is the capex plus the energy cost saving in here. We have in the graph cost in euro, and we have the months of operations in here.
And in this one shows basically, if you just take it in a case where it's a retrofit project, and taking for the similar system, you say, because you have already amortized or depreciated the cost of the existing system. So even if you just based on energy savings, the amount of the payback is within almost 15 months. So within 2 years, that's a pretty good business case when you look at from the economics feasibility side as well. So now going into you have any questions?
I mean, just to highlight something here in the RO units, when we built our system, it's based on the pumps mainly. The cost of the pump is the highest, let's say, capex for the RO. And then if you can see here, we have the system cost around 88,000 euro. Comparing to what they have existing, it's a bit expensive than what they have, but we prove it in the payback time.
Just to add one thing on this is that when coming from India myself, I see a lot of focus on the capital investment at the first from the customer or the end user side. But we ourselves, when we're looking at buying a Tesla or any car for that matter, we are looking at the total cost of ownership. And the capital cost of an ERD or a high pressure pump is only 9% of the whole RO unit, whereas the electricity consumption is around 55%. So you can have the cheapest pump and the ERD, but then the total overall consumption over the next 10 years, you'll be suffering with the operating cost. And that is where we provide a solution to reduce not just the total cost of ownership, but also then the emissions as well.
It's related to the iceberg, what we have it. So what we can see in our eyes is and under the water, it's much bigger. And back to Paul, maybe you mentioned Saudi Arabia, so it's not far from where I live, but I mean we were filling our tank with $1 or $2 in terms of fuel. Now it is more than $25, so the cost is increasing, and the attention for the governments and the countries on the energy consumption is a must now. So for you, maybe
So now we talked about the how the pumps can be put in parallel, and this is a case story for ZLD from China, where the customer had where they had already a biochemical treatment plant or facility where they had a first stage RO, and they wanted to increase the operational efficiency and reduce the discharge as well as reduce the recovery rate of the system. So here the challenge was basically how do they because China is also very price sensitive market, and the challenge here was, or the key requirement was, how to get the best energy efficiency of the whole system wherein they can have a consistent water production. And here we have four in total 26 pumps of different flow size. So it's basically the first stage has 43 cubic meter per flow APP, and then it reduces as you go higher up the concentration to reduce the brine or the reject water and increase the water recovery. And this was something, a testimony that what they appreciated was the reliability and the profitability that brings to the whole operation of the facility, contributed by the reducing the energy consumption and the cost. But this one is interesting because this company was under the pressure by the government. So the situation was that the ZLD regulations were enforced by the government, or stricter regulations were enforced by the government in China to reduce the discharge. And if they didn't do it within a certain time frame, that was around 8 to 12 months, they had to close the facility. So that would mean really taking a toll on the business. And the challenge here was not just to reduce the energy consumption and get the best technology or best way to reduce the discharge, but in the quickest time. And this project took from almost 6 months from designing to commissioning the whole system, which is a 30,000 CMD project with a 60% recovery, and it has different stages. So it is going up to 120 bar application. And this was a special testament from the customers that we were able to help or contribute among other partners to really help their facility, keep afloat.
And that's where we spoke about it, about the high pressure. They were using the conventional systems in wastewater, and they implement the high pressure system or high membrane, when we call it membrane. And then they increase the recovery up to 60% and even the production for this plant. And that's also a testimony from the customer.
So because here this was, I think they really appreciated the fact that we were able to, with our partners, able to realize this facility within 6 months and get their operations afloat, because I think that was the biggest thing for this whole paper mill in the company. That was a big challenge for them at that time. And this we are facing a lot. I know in Africa so far is not so prominent, but I see in India, even Europe, and many other countries where the government are enforcing these regulations on the discharge, because we have had so many SWRO plants or RO plants. But what happens to the brine now that is already being discharged? So what can be done? And in some cases, there are some really valuable minerals like lithium, magnesium, potassium, edible salt as well. I believe this is what a trend is going to follow for many years from today onwards, or it's already been picked up.
Yeah. So adding on this only. So the brine, we call it brine reuse or let's say brine mining. Brine reuse, mostly they are using back the water to irrigation system. That's also a way. And plus on the brine mining, when we say brine mining, they are extracting salts. So based on demand, sodium chloride, lithium, as you know that now it is picking up with the electrification and the battery system. So we can do a lot in this, and that's one of the example in China. We have another, maybe we didn't show it here, but one of the first commercial project in Indonesia where we are producing sodium chloride for food grade and a production of fresh water also. It's system based on patent technology, but it's going up to 83 bar up concentration to 220,000 ppm. Yeah.
And it's just to add on that, it's the largest brine mining project or salt production project in Indonesia. It has around 200,000 tons of salt production per year. So just for in-house in the country, in use in the country, basically it's an edible salt, and and as byproduct is water for them, the permeate, good water. So it's their key product was, and there we have actually recorded energy efficiency of almost 91.6% with our pumps. It has been in operation for over a year.
3 years.
3 years already.
Yeah.
Before I joined Danfoss, basically. So
Good. But yeah, that's it from my side. I mean, if there is any question, anything from your side, is that us know.
All right, thank you so much for that presentation. And I think this technology is quite interesting. Maybe us in South Africa, we can adopt it, especially because we are an energy challenged country. My question is basically taking you a little bit back from your previous presentation, because you said that the pressure and the pumping efficiency is independent of the pressure in the flow. I was just curious to find out that is the membrane material, how does that affect the pumping efficiency? The membrane material.
Of course, the membrane is the core. I mean, it's at the end, it's a game of membrane, the RO. It's not always about pumps. But by time, of course, the membrane need more pressure. Need to apply more pressure to have the needed or permeate. So in our design, always we have a safety factor, let's say, to contribute in that. That's on the first phase. Second phase, even in our technology, the axial piston, as I give you an example, any variation in the TDS on the feed, and because we're getting the feed and then pump it to the membrane. So at the same time, our pump can give the same efficiency. So if I need to give you, let's say, a 10 meter cube now, today on 40 bar, I can give you also the 10 meter cube on 80 bar with the same efficiency, with the same energy consumption designed for. So I mean, yes, it's always a damn game of membrane. Membrane need to be maintained very well. But I mean, as a production, for you as a client, you are protected in this. Yeah.
Thank you.
Thank you.
Well, my question is, at what point does it become useful to apply energy recovery devices? At what level of pressure do you start to see it being economically sensible?
I mean, I would say in the reject flow, when it come minimum to 7 or 8 meter cube per hour reject, so you can start to have a benefit for the energy recovery device. In terms of, because it's related again to power consumption. Mm-hmm. I mean, a plant of 200 meter cube per day, that's a start. You can use the energy recovery device, you can use the benefit. Less than that, I mean, it is always a capex for you more than the OpEx, yeah.
But that's presumably a seawater type situation?
Seawater.
Where you have a high TDS water. What TDS, is there a point?
25,000.
Okay.
25,000. You can use in brackish, I mean, in the low system, 12,000, 50,000. But the impact of the energy saving is not what you aim for. I mean, the capex is always, you will pay more, I mean, cost-wise, and the payback time is much longer. But in seawater or the high pressure, will really apply. Yeah.
Okay, thank you.
Zach.
Your question. Thank you. So this question may end up just fizzling out as I think about it. So in seawater systems, you've got about a 40% recovery. So you're working out your kilowatt hours per cubic meter of permeate at I think you had numbers of like 1.9 kilowatt hours per cube of permeate. if you have a very high recovery brackish water system, so you're starting with lower TDS, say 5,000, 6,000, but you're running at, say, let's say you aim to 90% recovery. So you're still operating at high energy input, high kilowatts per cube. Is there going to your question, is there a point where energy recovery becomes interesting in those systems? And I'm trying to figure out if there's a threshold of how many kilowatts installed or kilowatt hours per cube of permeate. Where's the point where we should start thinking that energy recovery becomes interesting? Have I made a sensible question? I don't even know.
So again, it's related to the pressure that we start with. I mean, for brackish, we end up in 12 bar, let's say 14 bar. That's, we call it pressure. High brackish up to 18 bar or 20 bar. So it is related always to the pressure applied. Then it's equal kilowatt. That's where you need to apply the energy recovery device. I mean, it's a business case at the end. How you want to, let's say, design it for your client or at the design stage, the pressure applied, and then we always put, as I told you, a safety factor for, let's say, the changing in the temperature. I mean, after 7 years, and you need also to put in mind what is the, let's say, the age of an RO system. Let's take 10 years, and then everything will be rehabilitated again. So I mean, it's a complete business case, but in my opinion, it's pressure. I mean, when we have higher pressure, we have higher consumption. We need a device to save energy for us.
Okay, maybe I can carry on my thought process. So in these high recovery brackish water systems, I mean, you can be running up to 60 bar pressure because you're concentrating the brine continuously into the final stages. So maybe we should think about it in pressure rather than kilowatts or flow or size of system. Right?
No.
So maybe I can just add an answer here, because we see different applications, and some of them are on the lower pressure side, and some of the seawater, and some we are currently seeing 80, and some are requesting at 120 bar. So in general, what we've seen when we do these type of analysis for clients, roughly 35 bar, and the size of the lowest size being about 200 cubic meters of brine that you're recirculating. There you see about a 24-month payback time. So once you increase pressure and flow rate, that payback time reduces.
Well, if you're designing a reverse osmosis plant for seawater, and you have a 45% recovery, so if you have a megaliter feed, you're only getting 550 cubes out a day. When you're designing the plant, you have two components. You have the feed water pump, and you have the energy saving. With energy saving, that feed water plant is now only going to be half the size of the original plant if you did not have energy recovery, because you're going to recover the rest of the water. So now, instead of having a megaliter feed plant, a pump, you're now only going to be sitting with a 450 cubic meter a day feed pump, and the rest is going to go through energy recovery, which is going to use a small amount, because you're sitting with an excess of 90% energy recovery. And that makes a big difference as well in terms of space and costs and everything else. So it is not paying more for your energy saving device, it's paying considerably less for your high pressure pump.
Also reduces the whole capital cost and improves the efficiency of the system. So that's absolutely correct what you said.
How much contamination is there from the recycled water to the feed water when it goes through the energy recovery device? Is there any crossover? Yeah, mixing the brine and the feed. How much mixing do you have?
2.5. That's the normal in isobaric. 2.1 to 2.5%. That's the mixing on the brine side, right?
Yeah.
When the exchange happen.
Yeah.
You mean, yeah. That's the normal mixing ratio.
Okay. Is there any potential for bio contamination being recycled?
Biofouling, yeah.
Yeah.
Biofouling is always there. What we do in our device, it is motor driven. So we call it active, because you have two type of pressure exchanger, the passive one and the active one. Passive is totally controlled by the brine pressure, speed of the rotation, and then the biofouling will be there. But I mean, in our system, it's active one, and then it clean itself. That's what we call. So we can increase the speed, and then we would do it. In some of the cases, also we have something called overflushing. So we feed the RO more seawater, say we call it raw water, and then we can reduce the mixing on the feed membrane up to 1.1%. You can do it only with these active pressure exchangers. Yeah.
But just to add, the reason we didn't present here because we are still about to launch it and we didn't want to show it. But we have a AERD solution that is specifically for applications where no mixing is important when it calls up concentration applications. So it's called GenSafe, and I'll not go too much into this right now, but if you have any specific application for no mixing, is where no mixing is a key thing, or you cannot use any ERD, then we have a solution for that as well. Perfect. Thank you.
Thanks, guys. Then we ending off the afternoon with Lorraine on wastewater reuse applications. Excellent.
Okay, so like I said, I will be presenting 2 case studies this afternoon. So the first one is reuse in the pulp and paper industry, and the second one would be reuse for potable use, and that's municipal wastewater. So the first one is a project where we partnered with NIAS in the Netherlands, and that was, like I mentioned, reuse for the pulp and paper industry. And it's a circular water concept and what they call the water rotonde, which is in Dutch translated is a water circle, basically. So, so the challenge we had was there was 4 paper mills in the region of Eerbeek-Lunen, which were treated. Yeah, they produced wastewater. And the wastewater was treated by the Industrie Water Eerbeek. And these paper mills were also facing some pressure to reduce their groundwater usage. And that is due to the fact that even though the Netherlands is below sea level, we actually do have droughts there also. So basically the Industrie Water Eerbeek treats this wastewater, and they are also facing some environmental challenges. So they have been asked to also reduce their impact and increase water reuse. So the mills, these mills operate in an ecological sensitive area, and that was the reason for that. So there was a motivation to develop what is called the water rotonde, and with this water management system, we looked into different applications or different products to actually reuse this wastewater being produced. The vision, let me just give you a quick overview of the schematic here. So the 3 paper mills, which is these, the green blocks that you could see. So they all use well water, like I've mentioned. And this well water is being used to produce the paper, and the wastewater being produced then goes to the Industrie Water Eerbeek site, where it's being treated up to a point where the wastewater effluent has been softened, and then some of that water goes back to the River axial, and some of that water is then being reused in the factories again. So the idea was to make that a bit better and reuse a lot more of this water. So instead of discharging to the River axial, all of it would be reused, and that's where the circular water use comes in. So during the piloting or the demos that we ran, one of these water factories stopped operation. So eventually we only had two water treatment plants producing water going back to the Industrie Water Eerbeek. But yeah, so during the investigations, there was only the two the two paper factories that was producing wastewater. And during this total investigation, we also the partners investigated looking at how we can also deal with evaporation losses. And there came in that we would use some of the water from the River axial, as well as a smaller paper mill, which is this smart packaging solutions in Linen, and also a nearby, also a wastewater treatment plant, RZWE Brummen, where we also actually did a pilot with nanofiltration. So, our approach. In 2023, they looked at the engineering design of this entire process. NX Filtration got involved, and this is where we decided to apply our DNF80 membranes. The pilot that we ran there was a Mexpert XL, so it had 8 modules installed, and the flow rate was around 10 cubic meters per hour, which we wouldn't really say as a pilot, but it's more demo. And the main objectives here was to demonstrate that all of these products can be used to meet the paper mill specifications. We evaluated the reject and the brine, the brine handling streams, and we had to provide design inputs for a full-scale plant. And that full-scale plant is 450 cubic meters per hour. So, how did we do that? So the entire process then was taking that softened water from the wastewater treatment plant and putting it through a 2-stage DNF system. So we used the concentrate from the first stream and reintroduced that to a second stage nanofiltration before it went for activated carbon and then electrodialysis reversal. So the main objective of the nanofiltration system was to remove your organics, like I mentioned earlier, your CODs, turbidities, color, also some solids, a little bit of your calcium and magnesium that was left over, and then some sulfates. That concentrate was further treated by coagulation and flocculation to remove the CODs, and then went back to the treatment plant. The concentrate from the EDI, the electrodialysis has also gone through ion exchange for hard disk removal, and then the RO concentrate was also further treated. So we just mentioned a few advantages here of this entire system, and it was the fact that it was modular, so you could add modules, you could add any of the process steps as the plant grew further. Partial desalination, I believe that is part of the electrodialysis. Process is reliable, but we will see some of that in a little bit of the results. So just to visualize it, we've split the entire process into 3 main processes. So the first one was the water line, where the nanofiltration membranes were used, and there you could see at least the color of the samples that we've had at each step. So once again, taking the feed water through the nanofiltration and taking that higher concentrate, you could see the color is a bit more concentrated than the initial feed water, taking that right through to the product water. The concentrate loop, so as I mentioned, coagulation, flocculation, and then through a centrifuge, and obviously the centrifuge sludge has been is a waste, and then the centrate has been fed back to the industriewater Eerbeek. So the results, I mentioned earlier that we had one of the factories closed during while we were piloting, and even with that fluctuating feed, we still had stable membrane performance. So unfortunately, I do not have the flux and the permeability graphs here, but we are working on a paper that will be published before the end of this year. So that can also be distributed. So but mentioning that the feed water quality fluctuated, but we managed to recover the permeability and also the DPs during operation. The plant operated at a recovery of 90%, the nanofiltration plant, and a flux of 22.5 LMH, which is quite demanding, we would say. And COD removal rates of more than 90% was achieved, sulfate around 60%, and then your calcium hardness around 35%. And this was all with the DNF80 membrane. So that is the 800 Dalton. So the more open membrane of the two products that we have. And then just the key takeaways. Like I've mentioned, it was a robust and stable performance with the membranes. The downstream processes they were performing quite well, we would say, because you've got a good permeate that you form, and you put that through your GAC and your EDR. So they operate a lot better, which gives you lower regeneration frequency on your GAC, and then in turn lower OPEX on both of those downstream systems. It's a scalable solution, and we've demonstrated a high recovery concept due to the hollow fiber nanofiltration, concentrate recirculation, along with the RO brine treatment. So that was the first one. I don't know if you have any questions. Oh, sorry, it is a BAC. Yeah, sorry, it was a BAC. It's a mistake on our side. Thanks. Yeah, I think it also depends on the feed water quality. So it's always something that we could run through a projection and see if there's a possibility, if it would be a feasible application for us.
I think you got about 90% recovery. I don't see the solids loading into this plant, but I assume it was quite low because it's come from the treatment process through a softening stage and into the NF. So the TSS would be pretty low. Hey?
Yes, exactly. Okay. Yeah, so the TSS would be treated upfront. That also gives us a better operation in terms of cleaning. Okay, if no further questions, then I'll move to the second one. Let's see. Yeah, so this one is indirect potable reuse with our hollow fiber nanofiltration membranes in Leon, Mexico. So it's a reference case, the world's largest hollow fiber nanofiltration plant for municipal wastewater reuse. And actually this morning I've received in my inbox where we've, a press release where we've secured the second phase of this project. So that makes it in total 34 MLD municipal reuse plant for drinking water, which is quite magnificent, I would say. So basically here is we've been approached by Ecuador, who is our partner in Mexico, to help them with a membrane solution for municipal reuse for Sapal. And so the reason why was there's increasing droughts everywhere, like we've mentioned, but in Mexico, we've seen since 2023 to 2024, there's been a major, more than 80% of Leon's territory is in extreme drought. So, needless to say, they've reached day 0 actually in the city of Lyon. So I believe a while ago in Cape Town, we also nearly reached day 0, where we had to take 2-minute showers or so and don't drink the tap water and so. But here in Lyon, they've actually reached it, and I've spoken to some of those people, and they really did not have a single drop of water in their taps. So I think that is quite difficult to imagine for us. Well, in some cases we do have that. I'm talking now from a European point of view, but I know the challenges we also have in South African. So what happened was we've had quite a few quite a few factors contributing to day 0. It was extreme drought. There was no surface water available. The groundwater extraction was limited, and along with an increasing population and existing reuse practices was unable to alleviate this drought. They've reached day 0, and the city of Lyon was looking at taking their wastewater, and they call it the new era, to actually use that wastewater for their city to be able to have drinking water available. So along with Sepal, like I've mentioned, they are the municipality of Mexico, the Mexican water utility that provides the water. Equazor was they were the designer of the plant and the partner of NX Filtration in the area. So I believe it was last year at Aquatech, we secured the first phase of the project, which was about 17 megaliters per day. And this is it was one of the press releases back in the time. So the construction that's currently ongoing. So the municipal phase 1, which is 200 liters per second, they are currently constructing, busy with the civils, and commissioning is upcoming. And then for the second phase, as I've mentioned, we've now secured the order. So that will probably be in the next year, also commissioned. We ran a demo plant there with our DNF80 membranes, and that was in 2022. And the reason for them going with the full scale was that demo plant operated really well, and they could see that this could fit into their existing treatment scheme. Okay, so like I've mentioned, it's the first phase was 200 liters per second, 3 stages, feed and bleed, and also more than 85% recovery. Second stage is an exact duplicate of that, and in future, this municipal project will serve as basically as just as a validation that IPR, indirect potable reuse, can be used for future. And look, it's not a new thing. We've been doing it all over. I think I believe it's Namibia. I believe Cape Town is also now looking at in the Fora project, also looking at that. So. Okay, so the existing plant is, there's some pre-treatment, coagulation, flocculation, the primary sedimentation, and after you activated sludge, another secondary treatment. And this is then where the upgrade would come in, taking that secondary sediment, that secondary effluent, passing it through a 20 micron screen, and then directly into the hollow fiber nanofiltration membranes. From there, it will go through oxidation, ozone, an activated carbon polishing step, and then being pumped to a reservoir where it will then hopefully mix with some rainwater and then distributed to the drinking water plant, where it would be further treated and then distributed as drinking water. So water quality, what we've achieved, turbidity removal was 97%. This was based on the pilot unit that has been run. Color was removed more than 80%. Here the sulfates have been removed more than 80%. A little bit of aluminium, 65. chromium, also 93%. Your iron and your zinc was also removed. What we've shown with the pilot system was that it could be an energy efficient way to do indirect potable reuse, and again we're avoiding chemicals, so no coagulants, no flocculants being dosed before the membranes. Obviously with the previous steps, yes, but not with the membranes itself. Yeah, that is my end. Thank you. Any questions?
Thank you. Very, very interesting, Lorraine. On that reuse plant in Mexico, the IPR plant, was there any discussion before the project or in the planning on looking at UF versus NF? Because there are many indirect potable reuse plants that go, biological treatment, UF, advanced oxidation, without an RO step, and that's the approach that Cape Town is taking as well. They want to avoid RO because they don't want to deal with the brine, but they are looking at combinations of UF, carbon filtration and advanced oxidation. What drove the NF decision here is, I guess, my question.
Yeah, thanks for that question, Rob. Unfortunately, I do not have the details of that, but I can always find out and let you know. But I believe it is with the partnership that we have with Ecozar in Mexico that pushed our product to the municipalities.
I mean, if you go back to the slide that shows the water quality, I mean, there's
one.
Yeah. I imagine one of the benefits is the color removal, and removal of iron and metals and things as well as just direct filtration. What you wouldn't get with a UF. I'd be really interested to see if the combination of NF and the ozone in this case resulted in a lower ozone consumption. If you get better quality from the NF than you would with a UF, and that brings down your cost of advanced oxidation, which I think you've mentioned is ozone in the first stage of this project, right?
Yeah, that's it. So we also have done some test work on advanced oxidation, UV peroxide, along with nanofiltration, and what we've seen is a lower chemical consumption and also a lower UV dosage requirement. So I think it's the how do you call it? It's the
transmittance.
The transmittance is more than 98% in our permeate. So definitely, you don't have any particles that would take in the light, and also with the chemicals oxidation.
Cool. Thank you.
Physical parameters. Did you look into the biological parameters?
So in terms of bacteria and viruses, yeah. So we've got more than a 6 log removal LRV rating for our membranes. So I believe there is some data, just not shown here, unfortunately. Yes, it's recently validated. Yeah, it's 4 years. Yeah, we've recently validated that, along with I believe it's KWR in the Netherlands, so Research Foundation. No more questions? Right. Then, Kristen, would you please help me? And I just want to take this time, I've got the opportunity now to have the mic. I just want to congratulate, on behalf of NX Filtration, the Marsi Water team on 20 years of helping to contribute to clean water. And we've just got something small for each one of you, Pierre, Marius, and Derek, if you would come and just... So thank you and congratulations to you and the team.
Okay, thank you, everyone. That basically brings us to the close for today. There are still a few thank yous to just quickly go around. I want to say firstly thank you to the presenters for sharing your time, your knowledge, and your experience with us this morning. I think it was truly added value to not this morning, but also being here this week. It was a full week. You deserve your rest after this. So thank you for that. And we just have also a small token of gratitude. If you can just join us and we can just give it to you, Paul, Dan, Amor, Omzi, Loreen.
You give something. So is that simple as sir?
Thank you, guys. Then I'd like to thank Uncapped Media for their support on the audio and visual components. We've worked with them previously and they really provide valuable insight and support to make the presenters look and sound good. So thank you for that, guys. The presentation material and recordings will also be made available to you. So that's also a critical part of this. So if you were going to ask the question, I think that's answered now. Thanks to Courtyard Waterfall for hosting us this morning. And then we have a special person that I'd like to thank. Kirsten has been running around this week and managing everything. If it wasn't for her, we would have been running around like headless chickens. So thank you for being the foundation this week. And we have a small token of gratitude for you too. Thank you very much. Oh, sure. And then lastly, thank you to everyone for making your time available. I think water is severely undervalued. And each of you in your various ways are water stewards. So thank you for looking after water, and we all still have the responsibility to continue with this work wherever you are. But if you're here this morning, then I truly believe that water is important for you. Thank you for spending your time with us. We value it. Please enjoy the lunch that is outside. Have a few more discussions. Ask the questions that you'd like to ask. But if you do not get to the experts now, we know where they live. So please get into contact with us or directly into contact with them, and then we'll make it happen. So thank you again for your time, and enjoy the rest of your Friday. Thank you.